Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we were discussing about the L plus alanine. How that L plus alanine, there on the basis of their Chiron approach, we have seen retrosynthetic strategy and we got the precursor, which is a chiral precursor or that template, that type of the thing, and by using as a proper reagent we have arrived or we have synthesized that L plus alanine. So what we are going to discuss today, now we are learning the utilization of basic concept in the synthesis of there are 6 molecules are there, and so far we have learned 3 molecules. So today is a 4th one. So the name of that is a multistatin, and you might be knowing the structure of multistatin is this one. This is a structure of multistatin. This is a structure of multistatin, as we know that this is a chair form type of the compound is there, and here this is a structure of multistatin, right? So this is a structure of multistatin, and this this multistatin can be prepared by the by using as a D-glucose, as well as we can prepare this by using as a D-mannose. We will see shortly. Before that, let us see the synthesis of multistatin from D-glucose was can be prepared, as well as here we discuss the another approach to this molecule which utilizes R-glyceraldehyde as the starting material and lead to the formation of the isomeric multistatin. And when we are getting as isomeric multistatin, there are the very difficult to isolate such type of the isomeric compounds are there. The most approach consists of securing the stereochemistry of C1 bearing the 6-membered ring oxygen and building up the remaining carbon backbone of the molecule by chain extension from the aldehyde end of R-glyceraldehyde. And no consideration was given to controlling the stereochemistry of methyl bearing carbon atom as in the previous synthesis from a D-glucose, and thus R-glyceraldehyde was chain extended to give the isopenyl derivatives, and which was hydrolyzed and chain extended again via iodide to give a mixture of ketones. Acid treatment gave a mixture of diastereomeric multistatin, from which the desired leo-rotatory 1s, 2r or 5r isomer was isolated by chromatography, and that is there. Now let us look at first one is a retrosynthetic analysis. As we know that usually we are doing first thing is a retrosynthetic analysis, right? Retrosynthetic analysis, this is our first point. So as we know that this is our target molecule, and as we know that target molecule means what? The molecule whose synthesis being planned is called as a target molecule, and here retrosynthetic analysis means what? The process of breaking down the target molecule into convenient starting material by disconnection and FGI is known as retrosynthetic analysis. And we disconnection and the FGI. Disconnection means what? An analytical operation which break a bond and convert a molecule into a possible starting material is known as a disconnection. And FGI means what? Functional group interconversion. One of the functional group converted into another functional group, so that disconnection becomes possible. But here we specifically using as a Chiron approach, there should be a chiral precursor, means carbohydrate type of the symmetry must be present there apparent, and then we thinking about that way. Here we are restricting our discussion with this carbohydrate type of the chemistry, and therefore while disconnection, you always keep the Chiron approach over there. So this is a retrosynthetic analysis. Let us draw this again as a structure. This one, this is a structure of chair type of the form of this structure. This one. Then in chair form, the substituent prefer to stay at equatorial position, as we know that. And this is a this is a structure of multistatin. And now the first step is this is a disconnection arrow, and writing over the FGI, functional group interconversion, over it. So here what you are going to get, you look at here OO, and here maybe as a ketone type of the diol. We are going to break this compound in such a way that, so we will keep the stereochemistry over here like this. So here, not let me draw properly this structure. So this is a structure. Generally this methyl group, they are as it is. Then we can see here, there you can write OR, and here also as a OR. Then this bond, there is a methyl group, and here as we know that there will be on that side we are this one, and then double bond O, and this ethyl group is there. So ethyl group. Here you can mention as a methyl over here, methyl at the end of methyl. This is we have broken this compound. From here we get diol over there, CH2, and after that again do the FGI, functional group interconversion. Again a functional group interconversion means what? One of the functional group is converted into another, so that disconnection becomes as a possible. And by recollecting this, you can draw the structure like this. This is a X, and here you can put OR and OR, and this side only as a methyl 2, because we are doing as a this one retrosynthetic analysis. Now this one again do the FGI, functional group interconversion. What you can write here, you can write this one like this. Here is a C double bond O, this methyl group, and we are writing this OR and this OR as it is. And after that we can convert this molecule, that FGI, functional group interconversion, and the starting compound will be the glyceraldehyde, right? That protects CHO, then OR and OR. This is a glyceraldehyde type of the protected glyceraldehyde, which is a starting material here. And now this again do the FGI, functional group interconversion, and this type of the glyceraldehyde we can obtain from this one. As we know that OH, 2 hydroxy group on the left hand side and 2 hydroxy group, 3 hydroxy group are on the right hand side. As we know that this is a D-mannitol. D-mannitol, and D-mannitol can be obtained from, as we know that FGI, functional group interconversion, it can be obtained from D-mannose, right? There is a 2 hydroxy group, they are on the left hand side, and 3 hydroxy group which are on the right hand side, right? And so this is the structure of D-mannose. This is the structure of D-mannose, right? So in this way, D-mannose, this is a starting compound or the precursor we got over here, and this is a general what we can call it as a retrosynthetic analysis. And as we know that retrosynthetic analysis means what? The process of breaking down the target molecule into convenient starting material by using disconnection, and FGI is known as a retrosynthetic analysis. Now look at here, and as we know that this is a retrosynthesis, and as we know that retrosynthesis means what? An imaginary but logical reverse chemical reaction which help us to reach the reactant starting from the target molecule is known as a retrosynthesis. And here look at, this is our target molecule, right? This is our target molecule, and target molecule is nothing but the molecule whose synthesis being planned is called as the target molecule. And by doing this we can get this one, this will be converted, this molecule could be made from this, and again this is a reverse process. So here just we are introducing as a what we can call it as a carbonyl group over there, and this can be converted into as a benzaldehyde glyceraldehyde type. Then we are getting this type of the conversion in our previous synthesis we have from this type of the how we are arriving, how we are getting as a chiral precursor. So this is a retrosynthetic analysis, right? Now we are going to start as a synthesis. How we can do the synthesis of this? Let us see, starting from here we are going to synthesize that compound. Let me clean the board first, and then we can see how we can synthesize. Now is a synthesis over here, right? Now is a synthesis, and in the synthesis simultaneously mechanism also we are going to learn, because in our previous lecture I already explained or given most of the what we can call it as a mechanism. Now let us see here, actually second part is a synthesis, right? We already written here, this is a synthesis. Now let us see what is our starting compound. As we know that D-mannose, right? 2 HO on the left hand side, whereas 3 OH on the right hand side. This is a general trend. We are writing this compound on the basis of the Fischer projection formula. Now what will be the first step? First one, sodium borohydride in presence of methanol used as a solvent to carry out the reaction. What it will do? It will convert the aldehyde group into as a alcohol, and you are going to get over here this one OH and this OH, 2 hydroxy group on the left hand side and 3 hydroxy group are on the right hand side. Here I am talking about, not above one. So this is, we can flip anyway, because there are the single bond, there is a rotation is possible, so we can rotate anyway. So sodium. Now what is the next step? Generally we are using now 1,2-diol protection, right? For 1,2-diol protection, what is the reagent we generally using? We are generally using as a acetone in presence of the H plus. Mechanism we already know for this, and therefore what you are going to get? It is known for the 1,2-diol protection, and therefore you are going to get over here this one O. Generally we are writing as a, this is a better way for the representation of this group, and that's why we are showing like this. Then OH here, and then O, and this one, right? Look at this structure carefully. What do you see? There is a 1,2 diol still there. What will be the next? Generally we are saying, so same step, there we are using as a oxidative cleavage of that diol converted into as a 2 molecule of aldehyde. And what is the reagent? Do you know the name? Do you remember? Yes. What is that? That is a lead acid tetraacetate, OAC4 we are generally, and this we are employing the solvent used here is a benzene, right? Benzene we are using, and what is going to happen? The bond between these two get cleaved, and you are going to get as a 2 moles of this one, 2 molecules of protected this glyceraldehyde, right? So this is a general trend. Up to that we already learned, and now what we are going to do as a next one here, in this case we are going to use, there is a, here you remember Grignard's reagent we are going to use here, and as we know that Grignard's reagent here, methyl magnesium bromide, which is a Grignard's reagent. What the Grignard's reagent with that aldehyde, you are going to get as a secondary alcohol. Only formaldehyde gives a primary alcohol, whereas the rest of the aldehyde react with Grignard's reagent, gives the secondary alcohol, and therefore you are going to get over here the secondary alcohol. While carrying the reaction, we are going to take only 1 mole of that protected glyceraldehyde that you remember over here, and what you are going to get over here, after that you will get CH, then here Me, then secondary alcohol, and other thing remains as it is. Like this is a case, this is a compound we are going to get over there. Now this is a secondary alcohol, and now this secondary alcohol we are going to convert into aldehyde. What is the suitable reagent generally we are using here? Here we can use the reagent that is a Jones reagent. Do you remember Jones reagent? CrO3 in presence of acetone. This is a Jones reagent. Jones reagent, and what it will do? It will oxidize the secondary alcohol into as a ketone, and therefore you are going to get here this one, right? This is a compound you are going to get over there. Here is a O. Let me draw properly this one again. The compound which we are going to get over here, I am writing here properly. Let me draw C double bond over here. It is a methyl, and then this one O, and this protected, right? So what we did this oxidize, and now I am using the pH, what we can call it as pH3, P double bond CH2. What is it? It is a Wittig reagent, and we know that Wittig reagent, what it will do in a Wittig reagent. So this is going to attack on this, so there is a butane formation, and here that oxygen atom get replaced by the CH2. General mechanism is, suppose how we can show, suppose here the let's see here I am showing that one, pH3 then P double bond CH2, right? And then with that acetone, suppose let us see here acetone, right? General R we can call it. What is going to happen? This is going to react with that carbonyl group and that oxygen with this, and you are going to get here is a pH3P, then CH2, here oxygen atom, and here generally R1 R2 you can call R1 R2. So this is a butane formation takes place. And now this phosphorus having as a grade, the driving force to break this bond between carbon-carbon bond, driving force behind it, because that phosphorus having as a great affinity toward the oxygen, therefore this forming as a double bond over there, and yes, and here you are going to get this one, right, double bond over there, so that you are going to get here. So by showing this one, what do you get? You are going to get here just as a this one double bond CH2 and then O this one, right? This is a what we are converting that carbonyl group into as a olefinic group, right? And after that you convert this into as a alcohol, but alcohol should be on this side. What will be the suitable reagent? Do you think? Yes, there is a do you remember hydroboration oxidation reaction? Hydroboration oxidation reaction gives the alcohol according to as a anti-Markovnikov's rule, and therefore the reagent used there is a B2S6 in presence of THF, tetrahydrofuran, and second will be used as a H2O2 in presence of OH minus. What it will go? It will give you this one OH, and then this other thing, this protected group remains as it is because we are already protecting this, and we are getting as a this one, and this compound further treated with this one with TSCl in presence of pyridine, and this we already know that this is the group. Tosyl chloride group is used to protect the primary alcohol in this case, and what you are going to get over here, this will get protected OTS, means this is going to attack over there. So mechanism we already know that this one, and in this way we are going to get as a this compound, right? This is a protected tosyl group, and after that what you are going to use over here? For you want to introduce as a now let me clean the board again, this half of the part. Now what is going to happen here? There you are going to use lithium iodide in presence of acetone. What it will happen? Iodide get replaced by the OTS, and you are going to get the product here, this one iodine, and then this one, right? This is the compound we are going to get, and this compound further treated with 3-pentanone. Here is a 3-pentanone in pentanone enamine derivatives, and what we can call it as a ET, MgBr. If you do all this, what you are going to get? You are going to get the compound is like this. The compound which we are going to get here is this one. So by doing this, you are going to get the compound. This methyl group should be there, and this O and O, this is protected, and now this one O, this one, and this is a compound we are going to get Me, and this one is a Me. And now when this treated with hydrolyze it, you are going to get the product here. See, this is a very essential thing over here, and now hydrolyze it, H3O plus, and you are going to get your target molecule, which is this one. This is a target molecule you are going to get over here, then this one, then target molecule here O, then this one. This is our target molecule first, isomers. And as we know that isomer means what? This is our target molecule we got, and isomer means what? The having as the same molecular formula but different structure, so that isomers are separated by using as a different technique, just like as a chromatography, because there by using chromatography they have separated this isomer, but this is our minus Leo rotatory multistatin, which is useful in as per as natural product is concerned. I think with this we have completed as what we can call it as molecule number 4. Only 2 molecules are remaining. One is pentenomycin and last one is sicamic acid. That we will see in the next lecture. Let us stop today here. Have a nice day. Thank you.